Ladies and gentlemen, dear guests, dear colleagues, all welcome. I will be talking about the evaluation of solar energy potential in Ethiopia as power generation source, a case study at 100 selected cities in Ethiopia. Now the order of presentation, as usual, introduction, Ethiopia, aims of the study, some related work that is done previously in this field, material and method, that's what kind of tools we've used in order to analyze the data, results and discussion, and finally, conclusion. Introduction. You all know that renewable energy is a non-pollutant, environmentally friendly, clean source. And it replaces itself naturally by nature. And these days they have two categories. There's the traditional type, which uses hydropowers and of course the biomass, the garbage and everything that we burn. And the new range is the modern technology like solar energy, wind and ocean energy, tidal energy, things like that. And as we said, renewable energy sources are eco-friendly and clean. Now, since our topic, the focal point is Ethiopia, I'd like to talk a little bit about the Ethiopia country itself. It is located in the tropical zone lying above the equator and below the Tropic of Cancer. It is a boundary between the equator north to the Tropic of Cancer, and to the south is the Tropic of Capricorn. And it is a country that shows a negligible amount of, it's a country where renewable energy sources like solar energy sources is available with high potential, but the country itself shows a very negligible amount of exploiting this opportunity for various reasons. And energy sector development is very, very low in this country. The larger share of the population that lives in rural areas, these are the areas outside the city, in the countryside, and they mostly use creosote for lighting and solid bioenergy, it's energy that's generated from biomass, for cooking and heating, and obviously this creating a big air pollution inside the homes. Around 80% of the population in the country lives in the natural rural areas without access to electricity grid, and uses biomass energy sources such as wood, animal dung, charcoal, plant residue, grass clippings, any rubbish basically. In 2016, around 96% of the population in Ethiopia were affected by this household air population, which is not very surprising. Obviously, inefficient burning of this biomass does create gas emissions, it does create carbon dioxide, and obviously some particulate matter. And these gas emissions, of course, it is very harmful to human health. Electricity demand in Ethiopia rises by 11% per year. In 2006 was 2,400 gigawatt hour, and it is expected to rise to 11,000 gigawatt per hour in 2020. As the economy of Ethiopia increases, so does the demand for the energy, and this will eventually create a short supply for the energy sector because of the low growth of the energy in the country. A little bit about the land itself. Approximately the area that it covers is 1.1 million kilometer, and it's actually habitats. The number of people living in there is about 110 million. Now, okay, people cannot follow it, and I keep forgetting, and I keep reading it. I'm sorry about that. Okay, I think we'll just try this differently. aim of this study. The aim of the study was to evaluate solar energy potential as a power generation and financial feasibility for selected locations in these rural areas, which are the cities and towns in the countryside. And the objectives of the paper was to identify the strategy that minimizes the critical factors that affect the energy sector development. What are they? Why is it that it's so difficult to actually tap into this source of gold and people cannot doing it? Some of these issues are, as I will mention below, heavy economic burden on oil fuel imports, shortage of electricity generation capacity, consumption of biomass energy at high level, and obviously its impact on the health and environment, low level of access to electricity supply, inefficient energy utilization in all sectors, low growth in the renewable power industry, in addition to the growth of large-scale hydropower. Now, we are not the first one, obviously, to do some work in this area. There has been some work in the past studying Ethiopia, and we are just going to mention some of these. A study conducted by Tucho and the others show that the Ethiopia has a large amount of exploitable electricity potential of 0.2 petawatt hour from hydroelectric, 4 petawatt hour from wind, and about 7.5 petawatt from solar energy. That was 2014. And the techno-economic analysis of hybrid system, that is photovoltaic, wind and diesel combined, for a district in Ethiopia using Homer software. The findings show that the system is feasible. That was Tesama 2015, just to name a few more. Another hybrid system comprising of photovoltaic arrays and wind turbines and diesel generator with battery banks and power conditioned units for a standalone system using Homer software. Findings show that the huge utilizable solar energy potential was available at the site. That's Bekele and Bonea in 2012. Possibility study of electricity supply from the solar wind hybrid systems for 200 rural families at 4 locations using Homer software. The findings show that generator battery converter setup was effective system. Bekele and Palm, 2010. Just a few more. Assessment of factors that affect implementation of all solar energy technology in Ethiopia was conducted using logic model of analysis. The findings show that the well-educated, rich, and female-headed families adopt the technology. It also concluded that the adoption of the photovoltaic technology fosters economy. This was Gutta et al., 2017. Materials and methods. So what's up? We have the missing page here.
Something is missing.
Something is missing. Copied onto the other one.
No. Also here is missing. No.
Okay, we've used some estimation tools here. PVGIS, that's a Geographical Information System, GIS. PVWatt, the other one RedStream, which is a clean energy management software, and the other one is a global solar atlas map in order to run the simulation or the estimation. And the scenarios that we consider for this is the first scenario, photovoltaic system with 1 kilowatt installed capacity, and the total cost $1,430 US. were considered. This actually made of 3 monocrystalline fixed modules with an area approximately 100 feet square, which is about 10 square meter. Second scenario was the photovoltaic system with 3 kilowatt install capacity at a cost of $3,932 were considered. There were 9 monocrystalline fixed mounting modules with an area of 300 feet square, which is about 3 times the other one, about 30 square meter, 28 square meter. The third scenario, photovoltaic system with 5 kilowatt install capacity and system cost $6,792 were considered. There were 15 monocrystalline fixed mounting modules with an area of 500 feet square, which is about 50 square meter. Fourth scenario was for a 45 kilowatt install capacity at the cost of $145,000 approximately US dollar were considered. There were 150 monocrystalline fixed mounting modules with an area of approximately 4,500 feet square. Now, the feasibility study that we carried out using the clean energy management software REDS, the equity payback period and the cost of energy generation for each location were determined in this study. Some financial parameters were considered as follows. Some of these parameters are obviously economic, financial parameters, and they are very much based on the previously done works in general in Africa, in Ethiopia. Selected sites. At the beginning of the presentation, I did mention that we have used 100 selected sites. These sites, when we were selecting them, there was some factors that we have actually based the selection criteria. One of them was the accessibility of data, low attention paid to the country's solar energy potential, and poor effects to exploit this potential are some of the site selection factors. In addition, of course, adoption of solar voltaic technologies to respond to this technology was very slow, and there was only few studies have been attempted to assess this huge potential. And traditional use of biomass fuels in these areas are very high. So these were some of the factors when we were choosing these 100 cities in Ethiopia. These were some of the factors that we've used selecting them rather than just picking them randomly. That's the country, Ethiopia itself, which shows, I don't know whether you can see it on the screen, but there's about 100 cities scattered all over the place here, from west to north, east. We don't have one of those things to highlight anyway, but you can see anyway the country itself. The 100 cities are buried inside that map that you're looking at. Now, the results and discussion, and these results and discussions are actually based on the Global Solar Atlas map, one of those estimation tools that we did. And you can see that it's not very easy to show it, but if you look at the west of the... Okay, nearly finishing. Okay, you can see to the left of the island there's some green patches. They are the areas which is very low potential to generate potential solar energy, and you can see the top up north and the west and the north. Sorry, east and the north. That the areas are very greeny and yellowy and orangey, and the approximately 1,500 to 2,000 kilowatt per kilowatt peak, so which is a very good result. Based on the PV-GIS simulation, the annual horizontal solar radiation data in the selected cities varied from the 1730 to 2,481, and if you look at previously here, at the bottom, you will see the orange and yellow is approximately, it says 1,819 right at the end, towards the middle 1,600. So it's about 1,500 to 2,000 kilowatts per hour square meter solar radiation. Based on the PV watt simulation, they're about the same values. If you look at it, 1,790 to 2,300, they're approximately giving the same result. Maximum annual solar radiation was recorded in Asatia city in East Ethiopia, city located in East Ethiopia, and the lowest solar radiation was recorded in the Kechencha city located in North Ethiopia, and Yabalo city located in the southwest Ethiopia. Energy generation and capacity factor for Asaiti city located in the East Ethiopia, for 1 kilowatt PVGIS, we are getting 1,600. That is more than, that's the estimation. And our target was 1 kilowatt, just to point out some of the values. And PV watt system was actually giving 1,500 kilowatt per hour, which is approximately the same as, give or take about 10 to 11% error margin between these targets 1, 3, 5, 4, 45. What we are getting approximately 10 to 15% percentage error. Average capacity, it varies between 16 to 19%. And as you can appreciate, the amount of radiation available, regardless of the panels, regardless of how much megawatt, it's approximately the same, which is 2,200 between 2,000 approximately kilowatt hour per square meter. Let's speed up a little bit more. Daily solar radiation for tilted, 1 kilowatt, you can see 6.23, which is remaining approximately the same, the radiation as previously. And energy production and the number of years and the exported to grid, this is the payback and how much dollar per kilowatt you will be making. Conclusion, solar radiation potential in the country is very high, ranging from 1,700 to 2,000, approximately 500 kilowatt per hour per square meter. Asaita, located in Afar region, and Chelenko, located in Oromia region, where city is found to have the maximum and minimum solar irradiation potential, respectively. The average annual energy production cost is about $0.067 per kilowatt hour, and the maximum payback period was 6 years for a photovoltaic system for a small household, while average cost was $0.86 per kilowatt hour, and the maximum payback period was 18 years for 45 kilowatt grid connected to the PV system. The findings of this research will help governments and then various interested investors participating in rural energy development sector. The financial evaluation shows the system is economically viable or feasible. And thank you for listening.